All right, so I'm gonna go ahead and go over those 7 questions that y'all had today for your assignment. So I'm gonna go over them a couple different ways depending on, hold on one second, depending on different strategies that was on the video, or maybe you went over them with Miss Tate this morning, or something that you've learned in previous classrooms. And please forgive me while I am admitting people into the waiting room. All right, so the first question was, 3/4 of the students in 5th grade like to play soccer. 1/2 of the students like to play on a team. What fraction of the 5th grade students play soccer on a team? So that's kind of the basis of a multiplication problem where you're trying to have a quantity and you want to know. So you have go ahead and make sure all your computers are muted. I'm going to post this on the solution, so I don't want a lot of feedback noise. Thanks, ladies. Remember the basis of the multiplication problem is quantity times amount in each quantity. So our quantity here is 3/4 of students, and the amount in each group is going to be 1/2. So let's say I'm going to just draw that problem, and this is how we started learning it. So I'm going to draw that 3/4. All right, if your computer is not muted, you need to do that now. Thank you. Oops. All right. So here's my 3/4, and the shade in those three out of the 4. Goodness, technical issues. I'm showing yellow. All right, so here's my 3/4 of the students. So these are the 3/4 of the 5th graders that like to play soccer. Now, if these 3/4 of these 5th graders, only half of these are actually on a team. So then I'm going to show that. I'm going to overlap my pictures now. So let me show that with a pen. I'm going to use black. So on that same picture, I'm going to show half. So I'm going to cut the picture in half, and I'm going to use another highlighter, change that in blue, and now I'm going to shade half of my picture. And as you can see, that half part of it's turning green, and then the other is staying blue. So when you look at this picture, you're trying to see what parts of it turned, what's the overlapping part. So in this case, you have 3 pieces that have like overlap. You have one, 2, 3. So you have 3 out of the 1, 2, 3, 4, 5, 6, 7, 8. So you have 3/8. So your answer for number 1 would have been 3/8. If you had done that with the standard algorithm of numerator times numerator, denominator times denominator, you would have done 3/4. 3/4 times 1/2. So 3 times 3 is 3. Guys, bear with me. Sometimes the smart board does not work on the computer as well as it does on the actual smart board. So numerator times numerator, or 3 times 1, equals 3. Denominator times denominator, or 4 times 2, equals 8. So that would have been your final answer. So you have the picture format, or that we learned previously. You also have the algorithm that we have also learned previously. So if you have a question about this problem for number 1, go ahead and unmute yourself or ask. If you have not done the problem yet, or if you want to go back and correct it, make sure you have written down the correct answer. So take a moment, unmute yourself, ask me a question. If not, I'm going to go ahead and move on. Any questions? All right. Yes. Say one more time. Okay, speak up a little bit louder, babe. Yes. So it's where, if you did it where you drew the picture, it would be where the, if you drew the picture and you shaded in the parts, it'd be, remember how when we drew the picture and you might have shaded it differently or drew stripes one way and then drew them vertically or drew them horizontally, or maybe you used different colors. It's where did those colors or where did those stripes overlap? So that's why I used yellow and blue, because you could see the color change. I didn't color that yellow or green. I colored it blue. I used the color blue, but it changed to green because when you mix yellow and blue, it turns to green. So that showed you where it overlapped. So that when you took a half of 3/4, it was showing you what exactly is a half of 3/4. If you were to if you were to eat a half of a whole cake, you can visualize what you're eating. It'll look a lot different if you're taking a half of 3/4 of a cake. So you're having to visualize it a little bit different. Is that helping make sense? Okay. All right, let's move on to number 2. So this one was a little bit different. So you're trying to build a garden and you're looking for an area of 12 square feet. So how do I find area? Somebody unmute and tell me. Nope. So area, almost. Area equals length times width. So you threw one extra little piece in there. So I want it to be 12. So I have basically 12 equals length times width. So basically I need to see, what do I need to I need to multiply these together, and I need to see, well, which one, oh, these darn things keep moving. Which one is going to equal 12? But if I look at these, I can actually start taking a lot of these away before I even have to convert. Because before I multiply mixed numbers, I have to change them into improper fractions. Why can't I start taking a lot of these away? What who can make a sum, like what, why do I know I can start taking a lot of these away? Why not? Well, okay, what would happen if you multiplied 6? So you have this length. So you have this length of 6. You have this length of 6 feet and a little bit more. You have this length of 5, I'm sorry, you have this width of 5 and a little bit more. If you had a length of 6, darn it. I really miss the classroom, guys, if you haven't figured out that already. Let me see if I can check that. All right, if you had, okay, if you had a length of 6 and a width of 5, because right here, all right, if you had a length of 6 and a width of 5, your area would be what? 6 times 5. What would your area be? 6 times 5. Anybody? Come on, so y'all gotta, if y'all are here, y'all gotta participate. Go, you can unmute yourself. Talk. I'm trying to teach y'all good strategies that y'all can use as you move forward. We're talking about, rather than having to solve every single one and convert every single one into a mixed number, I'm sorry, from a mixed number into an improper fraction, how can I just start getting rid of a lot of problems or a lot of the possible answer choices? We just said area, we know area is length times width. We know the area must equal 12 because that's what it says in the problem. So if I have this first possible answer, it says length is going to equal 6 and a half feet. Width is going to be 5.5 feet. Is my area going to be more than 12 feet in that first choice? Does anybody want to give it a shot? What's it going to be at least? Look at the whole numbers. You have a whole number 6 and a whole number 5. Say again? We're not adding. What are we doing? We're multiplying. So what's 6 times 5? So we're going to have at least, I think someone's talking about, I can't hear you. We're going to have at least 30. We're actually going to have more than 30 because we still have to include that half a foot. So that can't be it because we know we need 12 feet because that's what our problem says. All right. Let's look at the next one. The next one says remember, we're just looking at our whole numbers right at the start. We have a whole 6 and a whole 2. If we multiply those together, like to find our area, what do we get? We get 12. But if we include that 3, 6, are we going to have more than 12? So can that be a possible answer choice? All right. It cannot be an answer choice because it's going to give us something that is greater than 12. So then that leaves us with 2 possible answers. So now we have 3 3/4 times 3 2/3. So I'm going to review real quick how to remember to change that into a mixed number. Gordy, if you can mute yourself, please. Thank you, sweetie. All right, good. Thank you. Now remember going back to that check mark. Remember, we multiply and then we add. So 3 times 4 is 12. Whoops. Plus our 3. So we have 15 over 4. 3 times 3 is 9. Plus our 2. So we have 11 over 3. So if we were to solve that, we need to just start multiplying it across. So you go back to that basic numerator times numerator, denominator times denominator. So you have 165 or 15 times 11. 4 times 3, 12. So if I took 165 and I divided that by 12, I'm going to have 13 and something over. So I know that can't be it. So that actually leaves me just with the final one right here. And just for sake of time, I'm not going to check that. But you would have to change. I'm going to just give you a brief. You would take your 10 whole, you would add a 1 to it, and then you would take your 10 and 1/5 and put that into a mixed number. I'm sorry, an improper fraction. All right, any questions on that? If you have a question, you can unmute yourself and ask. But just make sure you always look at your wholes first and try to just brainstorm your way through rather than having to solve every single one, because that's a good time saver. All right, let's look at 3. All right, area of a square. If you know that one side of a square is 2.5 inches long, how much is the other side? If the length is 2.5 inches, what is the width? Somebody unmute yourself and tell me. Anybody? I'll wait. Guys, I can't just give you the answers. I got to make you work for it. Say it again. Thank you, because squares have congruent and all equal sides. So we just said area is length times width. So we would do 2 and 1/2. Come on. 2 and 1/2 times 2 and 1/2. Oh, so I'm gonna put that into an improper fraction. 2 times 2 is 4, plus my 1 is 5. So 5/2 times 5/2. 5 times 5 is 10. 2 times 2 is 4. That is not a possible answer. So I got to ask myself, how many groups of 4 can I pull out? I can pull 2 groups of 4 out of 10. I would have 2 left over, and I bring my denominator back over. 2 and 2/4. Whoops, I made an error. 25, excuse me. So that would obviously change. 4 or 5, sorry. That should be 6. Excuse me. And that would be 1. So 6 groups of 4 out of 25. That would leave you 1 left over. So your final answer would be 6/1/4. I do apologize. I am sitting in a parking lot, so I'm a little distracted. And my smart board keeps messing up, but oh well. Simple little error. All right, if you have a question, quickly unmute yourself and ask away. All righty, let's go to the next one. All right, Brittany planted a fruit and vegetable garden. So she has 2/3 of her garden, and out of that 2/3, 3/4 of that. So this is like, just remember, a fraction of a fraction, always multiplication. So that's pretty clear. 2/3 times 3/4. Numerator times numerator. 2 times 3. 2 times 3 is, thank you. 3 times 4 is 12. And we all know 6 is half of 12, so that is equivalent to 1/2. Any questions? All right. All right, this is almost done. All right, this is actually a multi-step problem. So you have a 10, no, this is not a multi-step problem. All right, so you have a lap. It is 2 3/5. He ran 4 laps. How far did he run? So he has 4 groups. Each group is 2 3/5. So I got to take this 2 3/5 and I got to put it into an improper fraction. There's that little check mark that I need to do. 2 times 5 is 10, plus 3 is 13/5. What do I do to my 4 wholes? Lovely. So 4 times 13 is 52. I'm really not enjoying my computer right now. And then 1 times 5. So I can actually do that in my head because I know 5 times 10 is 50. So I can actually get 10 groups of 5 out of 52, and I would have 2 left over and bring my denominator right over. So that would leave me with 10 2/5. So he actually ran a little bit more than his 10K. All right, any questions on that one? Lovely, lovely. All right, next problem. This is a multi-step problem. So the Mrs. Bryant runs on a path that is 3 3/10 kilometers. And she's going to do that 4 days this week. So right away, we need to figure out what is that going to look like. Now, her overall goal is 16 kilometers. So you need to keep that in your head. So let's figure out if she runs for 4 days that week, how many kilometers will she run? So 3 times 10 I give my little check mark. 3 times 10 is 30. Times, or add my 3 is 30, 33 over 10. So remember, I just bring my denominator down. And then I'm gonna put my 1 under my whole 4. Multiply that out, and for sake of time, I'm not going to do it. 33 times 4 is 132. 10 times 1 is 10. Excuse me. And you can actually just skip count in your head by your tens to see how many. I do know that I can get 13 groups of 10, excuse me, out of 130. I would have 2 left over. Hold on one second. Out of 10. Did you have a question? What a question. Okay. But that I'm not done yet. And you actually see right here, you do see an equivalent answer. But the question is how much further do they have? So you would actually need to see what is 16 kilometers minus what they already ran of 13 and 2/10. So rather than having to find a common denominator and so on, you could actually just count onwards. So if I'm in so think about like if you're on a number line, if you're at 13 and 2/10, you're going to need 8/10 more, and then you're on 14. And if you're on 14, you're going to need 2 whole to get to 16. So your answer would be 2 and 8/10. So I go and I check it. Don't see anything, but I do see this. So I'm trying to think, is 4/5 equal to 8/10? And I say, okay, is 4/5 equal to 8/10? And it is, because times 2 times 2. So 2 and 4/5 is your full answer. Always make sure you're reading to the entirety of, excuse me, that question, because they did throw in that answer. So some of you might have got like finished it halfway. All right, so any questions on that one? All right, and I believe, yes, this is the last and final one. So this is just an area problem, and we've had 2 of these, I believe, so we all know area, length times width. So I'm just going to plug in my numbers. 4 times 4 and 2/3. Goodness gracious. Times 2 and 1/4. What do I do with these mixed numbers? Who wants to tell me? Hello, hello. What do I do with them? Can't leave them like that. There you go. Thank you, thank you. I believe that was Atalia. All right, so 4 times 3 is 12, plus my 2 is 14. Let me give. Square, do you have a question? I don't know who you are, though, babe. Who is that? Who is Square? Go ahead. Okay. All right, so 4 times 3 is 12, plus my 2. So 14 over 3. Do the same thing over to 2 and 1/4. 2 times 4 is 8, plus 1 is 9. So, oops. So I have 9. Come on. 9/4. And remember, when you were dealing with multiplying or dividing fractions, you do not have to have a common denominator. All right, so multiply them just straight across. Numerator times numerator, denominator times denominator. 3 times 4 is 12. 14 times 9 is 126. So this little bar, this fraction bar, is the same thing as me saying 126 divided by 12. If I were to work that out, and I did my long division over here, I would see that I could pull 10 groups of 12 out of 126. And 10 groups of 12 is 120. So I would have 6 left over, and I would have 12. So that could be your answer. You could even type in 126 over 12, or you could type in 10 and 5/10. or you could type in 10 and 1/2. These are all equivalent fractions and decimals. All is acceptable. All right. Let me go ahead and stop sharing. So make sure you've jotted that answer down for number 7.